This is my first YouTube tutorial regarding mathematics. Um, Today we will be going over the properties of logarithms, such as the product rule, quotient rule, or power rule. We also might cover the change of base rule, depending on how advanced we go into this tutorial. I'll be explaining to you guys the rules as well as the example problems that go along with them that I will provide, and I'll walk you through every step. So without further ado, I guess let's just go straight into it, okay? First we'll start with the product rule, okay? So the product rule. Right away you see the word product and product rule, which for me personally makes me immediately think of multiplication, and that's just what we're dealing with. So if you have a log, let's say base 6 of x times y, okay? So you have multiplication operation being done in this argument of this logarithm, okay? You could expand this logarithm to look like this. So log, keep the same base of 6 of x, and then add that to log, keep the same base of 6 of y, okay? So that's all that is. It's just a way to expand the logarithm when there is multiplication being done within the argument here. It is also very important to note that when it comes to addition, so if you have log base 6 x plus y, the logs do not distribute in this case, okay? So x plus y, alright, does not equal this, alright? That is algebraically incorrect, okay? So you're going to have to just keep it as log base 6 x plus y, okay? So that's something important to remember. Alright, so let's start getting into our next rule, okay? And that is the quotient rule, alright? Similarly to the product rule, when I look at the quotient rule, I immediately think of quotient, well, division, okay? So that's just what we're dealing with here. So if you log base 6 x over y, you maybe can infer that you could expand it as so: 6x minus log 6 of y. Okay. Similar to the product rule in regards of using addition or subtraction, but in this case subtraction. Okay, so when you are dividing, you're subtracting here, and again, to note that log base 6 x minus y does not equal this, okay? Let's keep it the same here. Again, algebraically this would be incorrect. Cannot do this. Alright, that is our quotient rule right there. And I know if things seem confusing now, we're gonna go through examples, so in the meantime just sit tight, okay? So finally, let's go through the power rule. Alright, now, like what I said before, I see the word power, I think of an exponent, okay? So we're going to be dealing with an exponent here. So let's say you have a log base 6 x, and that's just going to be raised to any nth power, okay? So we can manipulate this right here by putting this nth power to the front of the logarithm, okay? So we could rewrite this as n log 6 x, okay? So this right here, this n, can be moved in front. That's something to remember. One more rule I want to show you, so make sure you took notes on these, okay? There's one more rule that I want to show you guys, and it is the change of base rule, okay? So what this change of base formula is, it is log, let's say it's base c, b, over log base c of a. That can be turned into log base a of b. Okay, and vice versa. So we could even say, alright, so log base a of b can also be written as the natural log of b over natural log of a. Okay. And we could do an example with this in a bit, alright, but let's start with some examples of these previous rules. Okay, so the first question I'm going to give you guys to put this new rule in practice is log base 7. That's an ugly 7. 5 to the 4th. How would I expand this? Well, I hope you paused it and took a minute to figure it out yourself, but immediately I see this exponent up here, so I know to use the power rule, okay? So what do we do with the power rule? We move that exponent to the front. We rewrite our logarithm, so so ugly. You get the idea, okay? Without that power there. So that power just got moved to the front. Alright. That was our first question. If you got that, good job. If you didn't, that's okay. You're still practicing, okay? It's perfectly okay. Let's go into a new example, okay? Let's do log base 5 and the cubed root of a. Alright. So, how would we go about doing this one? I'll give you a little hint off the bat. A cubed root, right? So a cubed root of a is the same thing as saying a to the 1/3 power. Alright? Alright, well, I hope you took a little minute to yourself to try to figure this out. But again, so if we remember that a cubed root right here is the same as saying a to the 1/3 power, we could just use the power rule once again. Alright? So we can move the 1/3 to the front and write log base 5 of a. Alright, and then we want to make it, you know, cleaner. We could just say log base 5a over 3. Alright, so that would be our answer. If you got that, good job. If you didn't, again, it is okay. Alright? So let's say I have log base 2. I have x cubed times y. Let's raise that all to the 3rd. Okay, so right now I see immediately we have multiplication right here as well as an exponent. So we're going to use a combination of two different rules, okay? Now, if you thought of the product rule as well as the power rule, you would be correct to use those, okay? So I'll start off right here. So we know we could distribute this exponent into this multiplication operation here, okay? So this would turn into log base 2 x to the 9th times y to the 3rd. And from here we just use our product rule, okay? So we have, excuse me, we can use our product and power rule, okay? So I know I could split this up. X to the 9th. Remember, we use addition for this. Oh, and look, we could still expand this even more by using the power rule. Okay, so I'm going to come down here, and I'm going to finish up our answer with log base 2x plus 3 log base 2 y. Perfect. Okay, just like so. So if you managed to get that, great job. It's awesome. If you did, that's okay too. So we're just here to practice. Okay. So if we have log, so if we have log base 8, okay, and you have a over b to the 4th. Let's raise that up to the 5th. Okay. Now right off the bat, I see an exponent as well as division, so I know I'm going to have to use the power rule and the quotient rule here. Okay. So let's do this right here. I could rewrite this as log base 8 a to the 5th over b to the 20th. Okay, and see what all I did here is I moved this 5 to our a and b, so that means we multiply exponents. We're combining them like this. Okay. Okay, now from here we simply just use our quotient rule. Okay, so log base 8 a to the 5th minus log 8 b to the 20th. And we're not quite done. Okay. For our final step, we need to apply the power rule to each of these terms here. Okay. So we could simply write 5 log base 8 a minus 20 log base 8 b. Perfect. That is the right answer. Let's look at this problem right here. This is going to be our final problem because it's the trickiest, right? And this is solving a logarithm, alright? So let's solve this logarithm right here. I'm sorry. Alright. So, our objective with this problem right here is to, number one, use the change of base formula to solve it. And number two, identify what values of x could be raised to the 5th power and equal these respective numbers here. So we have 27 on this, in this term, and we have 81 in this term, okay? So what squared raised to the 5th equals 81, and what raised to the 5th equals 27, okay? So we're going to find that out right now. So I'm going to utilize change of base, okay? And I'm going to put these right here to base e. I'll use base e to turn these terms into natural logs, okay? So I could rewrite this respective term as the natural log of 27 over natural log of x. Okay. Now, I could write this respective term. Remember, we're using base e again. Okay, so it would be the natural log of 81 over the natural log of x squared. And that's all going to equal 5. Okay? Now, right here, again, we could utilize another one of our exponent rules. We can use the power, or logarithm rules. Okay, we could use the power rule down here. So we could rewrite this as 2 ln x. Okay, so that's what we're going to do right now. 2 ln x. Alright. Now, to make this more friendly to work with, I want the same denominator for each of these terms, okay? So I hope that you remember from algebra, in order to get like bases, we need to cross multiply, okay? Cross multiply here. Now, when you are cross multiplying these terms here, we already know we want a like base of 2 ln x, okay? And we can switch this to 2 ln 27 plus ln 81. Okay, equal that to 5. Now, this is where some basic algebra knowledge comes in, okay? Now, why did I do that? Because 3 squared equals 9, and I applied the power rule with my 3 squared, that would be here, and I combined it with the 2 up here to make 4. Okay, so 4 ln 3. Now, this is the easy part. We're just going to do some basic algebra. When you're adding logarithms, if the same argument is within these logarithms, so in this case it would be 3. It's 3 here, 3 here, it's the same. We could add these together. We are good to add them together. So we want like arguments here. So, how would we add them? We would add these leading numbers right here, okay? So 6 ln 3 plus 4 ln 3 equals 10 ln 3. And in order to isolate for x on this side, I know that I'm going to need to multiply this over to here. So that is going to equal 10 ln x. Alright, because I multiplied this over to this side, and this 2 was combined with this 5 to make 10. So 10 ln x. Okay, so now we're left with this. 10 ln 3 equals 10 ln x. So what are we going to do? Well, I see these like terms right here. 10 ln and 10 ln. So I'm going to divide by 10 ln on each side, okay, to get these canceled out and these canceled out, and I get x equals 3. Okay, that was our example of solving a logarithm problem using the change of base formula, as well as the power rule, as well as the product rule. So we got a real bang for our buck out of this problem right here. I will be posting weekly math tutorials so we can cover more of this stuff, as well as more content from pre-calculus, as well as algebra 2 and calculus 1 later on. Let me know how I can improve my teaching style here, or if you have any tweaks or adjustments. Any comments would be greatly appreciated. Thank you so much for watching, and bye-bye.